as you can see here, this is probably one of my favorite talk titles in the last couple of years, is Wasm I Right or Wasm I Wrong? I'm Taylor Thomas, this is David, so we'll go ahead and introduce ourselves real quick.
Hey, I'm David Justice, a co-chair for the Wasm working group, maintainer of Run WASI and SpinCube, two CNCF-based projects for WebAssembly. I'm the author of Go for DevOps and a contributor and champion for multiple WASI specifications. Also, my day job, I work at Microsoft as an engineering lead.
Yep, and I am Taylor, like I said. I am also a CNCF WASM working group co-chair. That's why we're giving this talk today. We're not giving it on behalf of our companies. We're mostly giving it on behalf of the working group. And I'm a longtime WASM community member. Been involved in WASM stuff, especially WASM Kubernetes since like 2019, and a longtime contributor in that space along with the various standards specifications. Day jobs, I'm an engineering director at Cosmonic, which is a startup in the WebAssembly space. So with that, this ugly slide is purposefully ugly because we're not going to spend a lot of time on it. This is the single slide of WASM history, so we level set. We want to level set here a little bit around what WASM is, how it came to be, and where kind of we are in the evolution. Everything here today is meant to be the unvarnished truth about what, like, where WebAssembly is at, where it's being used, those kind of things as we talk about it. And it started in 2013. I know it says 2014 on the ASM.js, but that was the latest available draft, and I didn't want to go spelunking for the original draft. So that's the very beginning of WebAssembly. And then it started as ASM.js and then became WebAssembly and was integrated into V8. Then it became a draft standard, and then it became a core W3C standard. So these are all standards-based things that are in the W3C, and it's very important that we understand that. So first off, let's talk about why we have WASM in the cloud. We've given these kind of talks before, so if you've attended these, we're sorry if this is a repeat, but this is very important for the level setting thing. On the left side, you'll see the reasons why WebAssembly was taken so seriously and then used in the browser so much was because it's an open W3C standard, like I mentioned. It's sandboxed by default because you're running untrusted code. You are small and fast. It's because like that time to first initial load matters a lot in the web space. You're polyglot because you might need different performance characteristics. A lot of times people are writing things in C, C++, Rust, those kind of things to be able to do performant web applications. Think things like Autodesk or in any of their suite, or like Adobe in any of their suite. Pretty high compute things that are needed there and performant. It's also portable, right? Like that's by definition. It has to work on Linux and Windows and Mac, and it has to work in all the browsers. Now, if you think about that, that's why I have these contrasted right next to each other, is those are the exact kind of things we want in the cloud. We want open standards. That's why we have the CNCF. That's why this conference exists. And then also, it's sandboxed by default. How many times have we said, oh, containers are so secure to be bitten by a CVE? Now, that's nobody's fault. Like, bugs happen. But that's just part of the technology. You don't have that as much inside of the WebAssembly space. It is very small and very fast, which matters a lot for like functions as a service with like your cold starts and other things. And it's also polyglot, which is very helpful in an ecosystem like this. Yes, we're very heavy into Go, but there's also a lot of people who do Python and Node and C# and whatever. So the other thing too here is that it's portable, and that's one of the things that's most powerful about this at its core level is that portability. We've always deceived ourselves when we say Docker's so portable. It's not. You're making a separate build for every single type of image and operating system you have. So yes, there's a lot of work there. It's better than what we had before, but you don't have the same portability that you do with WASM. So let's talk a little bit more about WASM itself and why is it important.
Yeah, thank you, Taylor. Do you remember that story that you once heard about write once, run anywhere? Yeah, I remember that story. I was really excited about that story. In university, I got super hyped about that. Well, I think WASM is our closest thing to it. And I think it actually reaches a lot of those things that .NET and Java aspired to be. We have the ability to take this binary file format, run it just about anywhere, and produce it with just about any language that you want. In many of the languages out there, there is tooling to produce WebAssembly binaries. This is the stack we want. We can run in browsers, we can run it on servers, we can run it on Edge. We can take it anywhere. We can build it from almost anything. Well, this brings us to the next thing. What does core WASM really look like? Core WASM high-level types and stuff? No. Core Wasm is a bunch of I32s. We're talking about pointers and lengths, which gives us really great flexibility. We can express strings as a beginning of a pointer all the way to its length end, and that's a really great way to do that. However, do you want to do that with all of your high-level types? Probably not. You're going to have to write custom ABIs to take those high-level types, those, their format in memory, and be able to describe them to WebAssembly. Now, what this actually ends up meaning is we have to write custom ABIs, custom application binary interfaces. And that is a very difficult, tedious, and error-prone job. So, we have tools for this. All right, anybody use gRPC? Protobuf? Heck yeah. Yeah, we all do, right? You may use it and not even know it. And it's fantastic. Well, we need a solution like .proto files. .proto files give you that description of what this high-level type needs to look like on the wire. Okay, that's fantastic, awesome. We have the same problem in WebAssembly. We need a little bit more expression than, say, proto files, so we have this file called wit. And wit gives us this high-level language to be able to describe the interface. And then, from the wit file, we have enough information to generate out ABIs in each language that you would like to use. So, do you want to do it 5 billion times? Do you want to write a ABI for every single gRPC endpoint you have? I hope the answer is no. If it's not no, you're a sick person. No, we don't want to. We want to generate that out.
Yeah, and this component model is very, very important because like David was saying, we can't drive that home enough. If you're using plain Wasm, especially in the cloud, you're using custom ABIs, which means you are locked into whoever or yourself, if you created it, using that specific library. David and I work on very different things in the WebAssembly space, where you're going to see some of the projects we work on in a second. And yet we're still able to use the same tooling and a lot of the same components and things that we create with each other's stuff because we're using this common ABI layer, which is the component model. And another thing that this lets you do is it lets you plug in what you need and when you need it. So everything is expressed in the terms of imports and exports. We always display these, those of us who've been in the WebAssembly space for a while, these little Lego-like nubs that connect together. But you can have a component that is written in Rust, for example, that is exporting something that is used by a component written in Go. And those languages don't have to know that they were written in that language. So that's where the name component comes from as well. You're composing these things together. And you can compose and pull apart and put more things together. You can compose on top of a composition, which lets you do some cool things around APIs and basically forward patching things as you release new features and versions. And so that's where we get into, well, what's in this component that we were talking about? So this is the same thing we were showing earlier. And you'll see that we have that core, the I30, we always jokingly call it numbers and trench coats. That's what the WebAssembly is underneath the hood. And so what's a component? Well, it's just this little layer and wrapper around it. It's a very, very thin veneer. You have the core Wasm module that is what, like the component model isn't encoding it different. It's using the same things underneath the hood. You have memories and all the things that are in there. And then you have this thin veneer that expresses your imports and exports. So is the first question is people like, is there overhead? There's overhead with WebAssembly anytime you do it, but there's very little here. It's basically a lifting and lowering of the types into those raw pointers and then back into concrete types for the language that it's in. That's it. That's all that's here. Now another thing, like we said, we're trying to be frank and straightforward about what the status of thing is, of the everything is in the Wasm ecosystem, and that is that the component model is very difficult to implement. But you do it once, and then it's all that it is this thin veneer. Anytime you have a runtime, you implement that once in the runtime, and everybody benefits from it, no matter which language. That is not the case with the custom ABIs. So when you look at these components, remember, there is some stuff around it, but it's very lightweight. It's not going to be your bottleneck in almost any instance. Obviously, as you start to get super high performant, we're not going to talk about that because then every bit and move matters. But for the general purpose use case, it's not going to affect you.
Okay, so WASI and the component model are still relatively nascent and evolving. So in the current release, in the 0.20 release, we are going through and evolving that slowly with non-breaking changes on regular time-based releases. It is progressing quite well, actually. Very soon here, we will have a release for version 0.3. Version 0.3 is going to introduce some cool new features, one of them being native async. So we'll be able to have async invocations of your components, and the model will run natively in your languages. This is fantastic. Beyond that, there will be a lot of very nice ergonomic improvements for the interfaces. All of this work is culminating and leading to a stable 1.0 release, hopefully as soon as possible, so that we can stabilize this and build really amazing applications.
And you'll see on the bottom here, we have these worlds that are listed. Worlds are just collections of interfaces that you can implement or export or whatever your choice is. And these worlds are things like WASI Cloud, which David and I work on. You saw actually a snippet of one of those, which is the key value interface earlier. You have things like WASI, TLS, and so on. These help bootstrap you into the ecosystem, and you can build on top of these or define your own interfaces. And once again, when you define your own interfaces, you're not creating a custom ABI. You're just using and leveraging the same ABI that's already there. So with that, is it going to load? Funny video? No, maybe.
One more quick.
No, oh well, fine.
Give it a play.
Give it a play. Anyway, we're going to have the Wasm Showdown. Anyway, so what we're going to actually do is have, we're going to go through basically the ecosystem right now and talk about some of the biggest projects that are out there. It's by no means exhaustive, but we wanted to give you a feel of the breadth of projects here. So this is going to be very lightning talk-esque for a second as we go through each of these things so you can know about the different projects. First up is the project I'm a maintainer of. It's called Wasm Cloud. It's an incubating project in the CNCF, and it is basically exactly what it does what it says on the tin right here. It's orchestration layer for Wasm, and it can bridge across multiple network topologies. And also, you talk about this composition. That composition can be done by anything fulfilling anything else wherever you'd like to, depending on how you wire it up. So it's very much something where you can wire up your own platform. You basically can program the platform entirely using Wasm.
All right, next up. So this is Spin. And again, I'm a little biased here. I'm a Spin contributor and a contributor to Spin Framework, which is a CNCF project. Spin allows you to build really cool microservice applications with WebAssembly components. Developer experience is pretty nice. It's a really great way to get started in WebAssembly if you aren't really deep into it. You can go kick the tires and have a lot of fun real quick.
There's also cool companies out there like Renderlet. Those are some friends we have in the Wasm ecosystem where they're using WASI WG to build graphics rendering pipelines. You don't even know necessarily that you're using Wasm underneath the hood, but it's powered by the component model and all these things we've been talking about.
Oh, this was a really cool one. So I'm a big fan of Zed, and when I saw them come out with their WebAssembly component extensions for Zed, I thought, my goodness, this is exactly what we want to see people building. We want to see people building these extensions. And so we recently had them onto the community meeting for the WebAssembly working group. They described their pains, they described the successes that they had. If you didn't see this video or if you weren't part of the meeting, please check it out. It was really cool, insightful.
There's also things out there like the Kube Scheduler Wasm extension, and that is actually ongoing work. And we have some really cool work being done here in this space in general. You're able to plug in things into the Wasm scheduler or things like policy. We'll see that down the line. There's actually a talk by, raise your hand, those of you over here who I know are doing the talk tomorrow, right? Talks tomorrow? Yeah, the talk's tomorrow where they're going to be talking about what they did with the component model, the challenges they've had with it. It's going to be really cool. So this is something that's also going on out in the ecosystem in this space.
Okay, another one that I'm very biased on. Hyperlight is a CNCF-based project that was born within Microsoft, in my group in Microsoft. And some of the engineers that are working on it are right here in the audience. Hyperlight Wasm is really neat because what it does is it provides you a hypervisor boundary around your WebAssembly components that you can execute and use a defense in-depth strategy with extremely low latency and high performance. Give it a try. It's really awesome if you are extra paranoid, like we are running public clouds.
Yeah, and this is one of the ones that I'm also very interested in doing and playing around with myself. I've been following it along for a while, and that's really cool. We also have things in other big public clouds. This is one of them. This is built on top of basically proxy Wasm, which is a custom ABI. It's not the component model, but this is like inside of Google Cloud. You have like service extensions where you can do proxy Wasm to plug in filters and other things into your pipelines. Pretty awesome tool, very flexible as well.
Oh, neat. All right, so Inspector Gadget. So Inspector Gadget allows you to instrument and collect information using eBPF. Now, last year around this time, we were talking with those folks, and a little bit of cross-pollination happened. We got them excited about WebAssembly, we got them excited about components and stuff like that, and so they added WebAssembly support to Inspector Gadget. You can write your gadgets that plug into their eBPF pipelines to go and collect the data that you want and customize it. It's really neat.
You also see this popping up in things like Nginx. So Nginx unit has WebAssembly support. Also, they have some component model support and are adding more. So you can basically build extensions to Nginx in high-performance server situations as well. So just once again, you start to see how many different kinds of products these things land in.
So come to kubewarden. So do you want to write your policies in whatever language of choice that you prefer? I would say that's probably a yes. This is a good way to do it. kubewarden exposes the ability for you to use WebAssembly to write your policies in your Kubernetes clusters.
You also have things like low-level runtime. So Wasm Edge is another CNCF project that's very much geared towards, as it's in the name, the edge, kind of edge devices. It has a lot of built-in things for AI and other cool goodies. It's batteries included. They have partial component model support and are implementing more constantly. So they're yet another implementation of all this that lets you have those cool extension features.
All right. This is a lot of them. This is very different than our last pages. So what these are databases. What if you could take your compute and move it directly next to your data? That would be kind of fun. It would be interesting. It would be useful. You don't have the latency of going back and forth from that data store. Now, each of these databases supply WebAssembly support in one way or another, whether it's UDFs or store procedures or some other way. You can extend that database functionality with your own compute written in the language of your choice. And this is why we are so excited. We are so excited because there are a ton of projects out there that are using WebAssembly in production today. You can do it too. There are some rough edges, but there's a lot of great work out there.
Yeah, and if you can't tell, the GIF is like a live view of David right now on stage with it. But really, this is exciting. The WebAssembly landscape is fairly huge. There's an actual dedicated Wasm section on the CNCF landscape if you want to see how many things it's in just inside of the CNCF. So let's talk a little bit about the future. The future is where this gets exciting. Really, let's talk about a few of those things here. We'll go into a little bit more about some of them in just a second, but really the future we see is it's a plugin model to end all plugin models. Right now, you have this confusing mess depending on what you're using. It could be a standard in, standard out interface. It could be just calling a raw binary. It could be gRPC. There's a whole bunch of different things that people use to extend with plugins. With a plugin model like this, you can start extending the scheduler in Kubernetes. You can do mutating webhooks this way. There's all sorts of these kind of things you can start plugging into systems that already exist with Wasm. And I'll show an example why that's important in a second. But it also gives you new ways to build and run applications. As someone who works in a Wasm cloud, that's very much what we're targeting with Wasm Cloud. When you start thinking of things as interfaces and things to be consumed to satisfy those interfaces, it starts to unlock very different ways of programming and building applications. And I think it's going to really make the developer experience and the platform building experience a lot better. But we also get things like integrating with existing tools here in the future. David's actually, I think, been doing a bunch with build packs, right?
Indeed. So at 2, you can come and check out the work we've done with build packs to create a much better experience for your development of WebAssembly. So if you look at how you go to compose components together and build them, it's quite a complicated recipe. But we can transform that. We can use the tools that we have available to us in the CNCF, the projects that exist today, to not only extend those projects, but to further the other projects that we have around us. So one of those is Cloud Native Build Packs. And I'm very excited to show you all how it becomes a one-liner to actually build your WebAssembly components.
Yeah, and I think you're doing that today, right, in a talk?
Indeed, 2 p.m.
Yeah, so we're really excited to see those kind of improvements in the future, because that is, once again, in terms of frankness, WebAssembly is a little bit finicky with how you, especially when you start composing things or putting them together. And in some of the languages, it results in a very chunky boy binary, or it can be a little bit janky, just to be honest. But what you can do with it is once you've set that up, you're able to build these really cool things, and people like David are really trying to make that even better. So let's do a little example of like the plugin thing, because I think this really helps illustrate how it can be useful beyond plugins, but it's something really relatable. So let's use kube control, okay? Kube control has plugins, right? They're pretty much arbitrary binaries, right? You have my plugin binary, right? So what happens? That plugin is just a random binary you have downloaded from the internet. Now, yes, we're all not dumb, yet we all still curl sudo bash. So, like, things happen. Well, what if that plugin does an OS read file of your Etsy password database? Oh no, like bad, right? That's the whole point. Like someone's just popped your whole machine with a single binary that's in there. Now let's compare that to what happens with the component model in WebAssembly. You have your plugin component and you see the world. The world comes in, so every component is self-describing. You know exactly what it's importing and exactly what it's exporting. And if you look at it and go, oh crap, they're using the file system. I don't want to use the file system. And gonna deny it. And then you're fine. So the whole point is that you're able to see exactly what's there and you can provide something. And this is a simple example, but you could say, I'm going to provide a virtual file system, or I'm going to provide access to the file system that only has access to a specific directory path, and so on and so forth. You're able to really tweak the security model here, but also extend all sorts of capabilities. Imagine this where you have something that says like import like Kubernetes : client, or Kubernetes : whatever interfaces you want to provide could be in there and given to a plugin. And then not every single plugin has to like pull in the Kubernetes CL, like client Go or any of those kind of things.
Whew, gosh, wouldn't it be nice to be able to pull in client Go?
Yes.
I don't know. Most people probably have not tried to do that. If you try to go pull into client Go right now and build that with TinyGo, you're going to have a bad day. It will not work because we are missing some bits that need to be implemented in TinyGo. There are a lot of things out there that would benefit from having really awesome Go support. If you think about the CNCF as a whole, so many of our projects are written in Go. And the old saying goes, C Go is not Go, right? So if you have to go and build your project, say to use Wasm time, the runtime that we most often use. Wasm time is a Rust project. We then have to do linking to C shared libraries. That is probably going to stop somebody cold in their tracks if they're a Go developer. I don't like to use C Go personally. I would prefer to use pure Go. And we do have a nice option for running WebAssembly modules in pure Go. WA0 is pretty solid. It's pretty good. We need to have that option for components. We need to be able to light this up in pure Go. This is what we're reaching out to you all for. I want to get people excited. We want to get people excited about the idea of what the CNCF ecosystem could be like if we had pure Go support for components. If we had pure Go support for WebAssembly components, the world is a much brighter place. I guarantee you, if you think about that.
Yeah, this is really what, like Dave was saying, this is one of the biggest invitations we have. If this interests you, this is what we need help with. Like I said, it's complicated, but you do it once and then everybody in the ecosystem benefits from it. And that's very powerful. Like, this is the way. This is how we do it. This is how we keep moving forward with the component model, especially in such a Go-heavy ecosystem like the CNCF. So with that, just a couple things of what can you do. Beyond that, that's the big one. There's a couple other things. You can also try out the projects we've recommended, and any of them. Try out the Wasm side, see what happens, see what you can figure out with what you can do. Give us all the feedback, all the rough edges, all of those things. We want that. Also, you can come see us at the Tag Runtime booth tonight. Both David and I will be there. We're going to have various, SpinCube's going to be there for a project, Wasm Cloud's going to be there for a little bit, and then the Wasm Working Group's going to be there a little bit tonight, all during the booth crawl in the late afternoon today. Come talk to us, learn more. And then you can also take a look at any of these QR codes to just see efforts that we've worked on. They're things that you can come, some of them you can still join in on. Others, they just serve as an example of things that we've done in the past, such as integrating with OCI. So with that, we'll go ahead and open things for questions. Okay, I think the mic up here is for questions, right? Yes, okay. So go ahead and come up if you're going to ask some questions so everyone can hear it on later recordings.
It might be a dumb question, but the hypervisor-based security layer, Hyperlight, I thought the whole point of Wasm was to provide a sandbox level of isolation. So why do you need a hypervisor as well?
That is a really fantastic question. So the sandbox of Wasm is in fact provably secure. That's what we rely upon. Now, WebAssembly itself doesn't necessarily, like Wasm itself, doesn't have any idea how to access a file system. It doesn't have any idea how to make an HTTP request. That functionality is actually provided from the host below the WebAssembly sandbox. So you can imagine in WASI HTTP, the interface for, say, outgoing HTTP requests, that function gets invoked. The host handles the request, then makes a request out to that HTTP server, brings back the response, passes it back into the guest being the WebAssembly sandbox. It then operates within the guest. Now, all of that stuff in the host is your trusted compute base. So, do you want to do that? There can be bugs in that section. And bugs in that section could lead to CVEs. For example, if you're accessing a file system, relative pathing, have we not seen millions of relative path issues across the years of how those are handled?
So the idea is like, just as a container relies on a shared kernel, if you're relying on this like shared services layer, which has a much larger attack surface, is that the...
Yes, no sharing of the kernel.
Yeah, it's very much for those when you're on that shared ecosystem like with functions. So for example, in contrast to something like Wasm Cloud, we don't expose file system access or even environment variable access by default. So that's taken care of because the other things enforce those. But when you have to give file system access or like raw socket level access, you need something in a very high trusted compute, like think something like Azure Functions or that kind of thing. You're going to need huge amounts of isolation. It's the same reason stuff like, why am I forgetting it all of a sudden? Firecracker exists even for containers. You could say, well, containers contain it, right? Well, sometimes you need a little bit of extra isolation, and it's very useful for that.
With containers, I get it though, because no one's saying a container is a sandbox. So, so yeah, I guess you could see this Hyperlight thing as micro VM for Wasm. Is that?
Oh,
that's a good way of stating it.
You can also use Hyperlight to run native C code and all sorts of other things too.
And just with I thought the whole point of WASI was that you didn't have direct file system access, so that's also...
You can see if you have direct file system access.
Okay.
How it's provided is entirely up to the host. Like I said, you can virtualize it, which is one of the big security benefits. So to be clear, like you can virtualize anything. If someone has a socket connection, you could be limiting what that socket's doing, or it could not even be a real network connection. For a file system, it could be in memory.
Right, okay.
That kind of thing.
Great, thanks so much.
Yeah.
Thank you, excellent question.
Any other questions? I think we have time for maybe one or two more, if anyone has any. Okay, awesome.
Thank you all so much. You've been an excellent audience.
And we'll hope to see you around.